In this lesson, we are going to look at angles. Okay, so to our left, you can see an angle. An angle is formed by two rays with a common endpoint. That common endpoint is called the vertex. And what it means by endpoint, it's basically its starting point, right there. The rays are called the sides, and you name an angle using 3 letters. The middle letter must always represent the vertex, so you're basically going in order right over here. So like angle ABC, which you can see right here. You can use a single letter if there's only one angle located at the vertex. So right now you're seeing only one angle located at that vertex. But there are cases when you have multiple angles located at one vertex, and so then you always have to use the 3 letters. You can only use one if there's only one angle. When you want to refer to the measure of an angle, so the fact that this is 60 degrees, you are going to use that lowercase m. The measure of angle ABC is equal to 60 degrees. This is angle ABC. The fact that it's 60 degrees is the measure of it. So now let's look at the types of angles. You have 4 types of angles. You have an acute angle, that means it's less than 90 degrees. You have an obtuse angle, and that means it's greater than 90 degrees. You have a right angle. A right angle is equal to 90 degrees. And then you have what's called a straight angle. And this angle is equal to 180 degrees. Alright, so looking at example 1, let's look at this one together. We're going to name the vertex of the angle first. The vertex of the angle would be K. That's where my 2 rays meet. The sides of the angle, we're going to name those from the vertex out, and they're rays, so we're going to write them as rays. So KJ and KL. There are 3 ways that we can name this angle. The first way, because it is an angle that's all by itself, I can name it angle K, just by its vertex. Or I can name it angle JKL, going from J to K to L. Or, finally, I can name it angle LKJ, basically just going the other way, and that works too. And this angle, to classify it, it's obviously greater than 90 degrees, so this is an obtuse angle. Try example 2 on your own. After completing example 2, this is what you should have. The vertex is S. You can name the sides SR, ST. 3 ways to name the angle right there. And S is in between on the other 2. And the angle is a right angle. So now looking at congruent angles. When the measures of the angles are exactly the same, then those angles are congruent. So we would say that the measure of angle A, or if the measure of angle A is equal to the measure of angle B, based on the example at the right, then the angles are congruent, and we would write that as angle A is congruent to angle B. So now let's look at an angle bisector. If you think of the word bisector, bi means two and sector is to section. That's where it comes from, a section. It's a section of something, right? So a bisector is a ray, or an angle bisector, is a ray that divides an angle into two congruent angles. So looking at the diagram on the right over here, BD is our angle bisector. And we would write that as BD with the ray on top because it's a ray. And because of this, we would say that this angle right here is going to be congruent to this angle, and we're going to separate it into two different angles. So it's not the same angle. So angle ABD is congruent to angle CBD. Now if you noticed, B is in the center of both of those because B is the vertex for both of those angles. But I couldn't call this angle B because they share more than one angle, or more than one angle shares the vertex. Put it that way. So perpendicular lines. You've probably seen perpendicular lines before. Let's define it. They're two lines that intersect at a right angle. So perpendicular lines are going to make a right angle. So if you know that lines are perpendicular, you should know that the angle that's created is 90 degrees. The symbol for perpendicular is this, basically two perpendicular lines. It's like an upside down capital T. So looking at the diagram to the right, when we see this line L and line M, if I wanted to make a statement of them being perpendicular, I would say L is perpendicular to M. Now, a perpendicular bisector is obviously very close to just perpendicular lines. It has the same definition there, but now we're looking at bisect. Just like angle bisect, it's something that's cutting something in half. It's two things, right? So a perpendicular bisector is a line, segment, or ray that is perpendicular. It's kind of like, well, no duh on that part, right? It's in the word, but we want to make sure that we're defining it. It's perpendicular to its segment at its midpoint. That's the area that you got to cut it in half, right? So at that midpoint, that's where it's perpendicular. In the diagram to the right, over here, we have these two lines. We have a line, LM, and we have a segment, PQ. So we can say that LM is the perpendicular bisector to PQ. So let's look at example 3 together, and then I'll have you do example 4. And you could look at example 4 in the key to see how you did. So in example 3, write another name for CBF. So let's go over here, and I have CBF, right? I didn't even have to look at that to know that. If I want to write another name for an angle, like an angle CBF, I'm going to just switch it around to angle FBC, because I cannot name it by its vertex. There's too many angles attached to it, so I can't do it. So name the sides of angle EBD. Alright, so I'm going to give you a helpful hint here so that you don't actually have to look at the angle for it when it wants you to name the sides, right? If you recall, the middle is the vertex, okay? So if I write BE or EB or whatever, I'm going to do BE because I like to go for my vertex out as a side and then go back to your vertex and then go out, BD as a side, you're going to be correct because that's what makes up the side. It's from the vertex out. So I would say BE and BD, and going from the vertex out. Now to classify angle ABC, this one I'm going to have to actually look at because I'm going to classify it. So I have A, B, C. That's obviously a straight angle. So that's straight. Now to give an example of an obtuse angle, you have multiple choices here. I'm going to do angle EBC, but you could have done angle EBD, you could have done ABF. There's lots of options here. Name two congruent angles. Well, coming over here, I can see that this has one arc and that has one arc. That means that those two angles are congruent. They have the same number of arcs inside of them. So I'm going to write that as angle EBA and angle, let's see, I want EBA, so I'm going to go FBC. And to name a perpendicular bisector, well, when I see these congruent marks right there, it means that it's being bisected in some way. So this is our perpendicular bisector. And this particular one, even though it has a line, we're talking about the segment that ends at this point. That's what's getting bisected, is where it ends. So the perpendicular bisector would be BD, and that's a ray. So I'm going to draw it as a ray.